Good afternoon. The title of our project is the design and simulation of hybrid system for Nain, Labrador. And these are the group information. The course title is ENG 9896 Renewable Energy Systems. We are group 14, and myself and my group member, my group mate in person of Chukwemeka Agui, and myself, the Joparinde, and our instructor, Prof. Tarek Ikba, are going to be on this project. So here is the content of how our project and presentation is going to go. This is the hierarchy at which we are going to arrange it. The first, we have the introduction. The second, we have the significance of study. The third part, we have the literature review. The fourth part, we have the methodology. The fifth part, we have the system design and simulation. The sixth part, we have the system results. And the last part, we have the discussion and conclusion. We have included a diagrammatic expression of location of Nain beside our content, which is on the right side. I move on to the introduction to this topic. This project involves the design and simulation of hybrid power system for a Nain Labrador. The system design will be implemented using a steady state and dynamic modeling to select the best cost-effective economic solution and system control for Labrador. We can achieve this by using software called OMA Pro. And then the renewable energy system contains several subsystems, part of which I'll be listing. We have wind turbine, we have the solar PV system, the storage system, which is the battery, the grid connected inverter, and the load. And the system generally run on either a standalone mode or a grid connection mode for providing a reliable power to loads. Due to the multi-source operation and decentralized distribution of the soft system, and how to achieve a better energy system design, this simulation is one of the best topics that we can discuss on hybrid power generation research. So I then move on to the significance of this project. What are the significance of this project? First is to provide a solution to ease the problem of rising energy prices. This is in addition to lowering greenhouse gases. The cost saving from use of renewable energies can be spent inside the economic and used for local wealth creation. Second is to identify and address the issue of remote communities so reliance on fossil fuel generator for energy. The new Labrador system, located on the province of Newfoundland and Labrador Northern Coast, is the subject of this project. A city of over 800 people and are not linked to electrical grid. They primarily rely on diesel power generation at this computer age. So part of our significance of this problem is to provide a solution to that particular problem. And lastly, on our significance of this project is to serve as education tool to inform design engineers, scientists, and other pertinent parties, as well as decision makers, of the availability of convincing design solution that would offer rural population an affordable and environmental friendly energy. So I move on to the literature review of this paper. The hybrid renewable system is not only capable of delivering power massively but also in an effective way. It's not only delivering power, but it delivers it in an effective way. Mashoud et al. Proposed an off-grid wind diesel hybrid system incorporating a CHP technology on an island of Bangladesh to supply the energy demand of 168 MW per day. The hybrid system was then able to reduce CO2 by 33,053 metric tons per year, which is of course very important consideration to be considered when we are implementing our hybrid system at Nain Labrador. Takashish et al. Proposed a coordinated control method for hydrogen production from wind power, which effectively reduces the impact of the wind fluctuation on the power system. And Bellemakta et al. Proposed an optimized control method based on based on the technological principle of hydrogen production by wind power, which effectively improved the efficiency of this system. Past research on this particular topic has given us feasibility that embarking on on this research will give us the needed result that we need and to solve the problem of Nain Labrador. So methodology of achieving this research of ours. So OMA software and MATLAB software were used to analyze the proposed system, performance and feasibility of the chosen location, as well as the design of control system using system records from the utility distribution company that was done to ensure that the research project met and adhered to the high quality engineering standards too. So the economic analysis, the total connected load for the Nain Labrador area is first calculated. This total calculation load will serve as the fundamental input for our system. The next stage will be identify the additional system component required to run the suggested system. After looking at the research area to decide the hybrid system, configuration depending on availability of wind, solar and other energy source. Then we move on to the battery storage and converter control system. Determine the cost parameters for the proposed system such as original cost, operation maintenance, replacement cost is required for the final. So I then move on to the design structure. So the design structure of Nain Labrador is divided into two. We have the steady state design and we have the dynamic design. The steady state design can be described using or can be implemented using OMA software. While the dynamic state we have to use MATLAB simulation. So for the steady state design, we have load components, wind and solar GIS as our resource selection. But for the MATLAB, we have the system sizing as load and components and system programs, where we have to include our code, designs and our inputs in order to achieve this aim and have our results of the proposed system and proposed thing that we want to achieve.
Now we'll be looking at the system design and its simulations. The proposed hybrid system is developed on OMA Pro and consists of a PV panel, a wind turbine, a battery, an inverter, and our electric load. The wind turbine is a 2 MW versus wind turbine that uses a double fed generator that can individually adapt to a 4-pole 50 Hz and a 6-pole 60 Hz. The capital cost of this wind turbine is $2 million. The replacement cost is $1.5 million. The operation and maintenance is $150,000 per year. The selected PV panel is Canadian Solar CS6 with 330p. This PV panel has 72 cells and is a polycrystalline solar screen. Each screen has a capacity of 330 watts and the capital cost of this PV panel is $220. Also in our schematics, you see our electric load. The load profile used here depicts the daily load profile for Nain Labrador, gotten from NL Hydro for 2020. During the winter season, the peak power is 1,923. Our hybrid system has low availability. The system is provided for by a 12-volt battery system. The selected battery is a Trojan SAGM 12SO205. This battery has a nominal voltage of 12 volts, nominal capacity of 2.63 kilowatt hours, maximum capacity of 219 amp hours, has a capital cost of $650 and a replacement cost of $555. Also selected for this project is an inverter which has a capacity of 2000 kilowatts. This inverter is used for the purpose of converting DC to AC and has a capital cost of $200,000, a replacement cost of $185,000, and operations and maintenance cost of $2,000 per year. During our optimization analysis, the best optimized result shows that the wind turbine provides 91% of the needed energy. The diesel power plant provides 8.75%, while the PV provides 0.225% of the needed energy. The levelized cost of energy is about $0.389, which is cheaper compared to the current cost of $0.7, which is being paid by the residents of Nain Labrador when all profits and overhead costs is added. We'll be looking at the system control and design analysis of the proposed hybrid system. The purpose of dynamic modeling and simulation is to determine if the proposed system can maintain a steady state response during various system changes. In the diagram, we can see the system designed to control the wind turbine. The wind turbine will be controlled using pitch controlled proportional gain, which is used to regulate the output of the voltage. The PV array, which converts solar irradiance into electrical power, is controlled using the point tracker, the MPPT control, which optimizes its power by regulating the output of the PV array using incremental conductance approach. Also, for the battery system, we'll be having a straightforward protection system which is aimed to stop overvoltage and undervoltage of the battery storage. The resulting output voltage from the hybrid system presents a steady state output waveform with minor distortion. Most significantly, we can see that the output voltage level is within the normal voltage of plus or minus 2% range. Running a hybrid system for rural communities involves considering several factors, including the energy needs, the available resources, the environmental impact, and the cost effectiveness of the system. The hybrid system should be designed to meet the energy needs while also being sustainable and affordable. A well-designed hybrid system can provide a reliable and sustainable source of power for rural communities, improving their quality of life and contributing to their economic development. For Nain, Labrador, a hybrid power system was proposed in this research. In order to generate ideas for developing a system for Nain, we first looked into existing publications that had investigated comparable off-grid hybrid energy systems. The load profile for the area, the current diesel generator system, and the available natural resources, particularly wind and solar, were considered. This research then suggests a hybrid system schematic and estimates components cost using HOMAPRO. Afterwards, several system architectures were simulated using the program, and based on variables like the levelized cost of energy and net present cost, the best solution is chosen. Maximum renewable energy penetration for the chosen system architecture is 66.3%, the net present cost of $47,454,002, and an energy cost of 0.389. The system architecture is judged practical because it approximately 100% lowers energy costs for the people of Nain. The system proposed in this project is both feasible and practical and can be implemented in rural areas to improve their energy supply. One of the disadvantages of our system is the availability of resources. As for Nain, the wind resource and also solar irradiance were sufficient in order to carry the materials in this project. But for locations that do not have this natural resource available in the required amount, this system might not work effectively. Another advantage of this system is the cost. This project cannot be undertaken alone by an individual or a group of individuals, but companies and also government need to come together in order to set up such a project for developing communities. Governments are also encouraged to support researchers who need to tailor this proposed system to their own community and also support project development in order for it to be maintained and adequately and effectively created.
To buttress the point that my group member make, a lot of young researchers has been met with discouragement along the line. Haven't detected something that will be of a big solution to developing areas and that will solve their problem for years. Discouragement of government has led to the discontinuity of this project, which has caused discouragement for young developers like us. When they detect the project and a feasible solution, if the government is not ready to cater for such solution, or they are not being encouraged by the government, such a project cannot be feasible and cannot be done, and then students are discouraged by getting this project done. So finally, I thank you all for listening to our presentation. I hope we've been able to pass the necessary message that hybrid system will solve the problem of Nain Labrador. Thank you.